Hello wonderful person, this is Anton, and today we're going to be talking about a pretty incredible discovery that was always there, right in front of us, but we just didn't really see it. The discovery of this absolutely colossal object that represents the largest supernova remnant we've ever seen. Something that's about 90 times the size of the full moon in the night skies. But the thing is, we've only discovered it now. So something is definitely not adding up here. But let me explain to you what's going on and why this is actually a pretty big discovery. First of all, light, or light spectrum as it's known, is basically something that we use to perceive the world around us. But the thing is, our eyes are only capable of receiving about 0.0035% of the entire light spectrum, meaning that 99.65% of the light spectrum is actually invisible to us. Did I get this right? Which means that there are definitely a lot of things out there in the beautiful night skies that are actually invisible to our eyes. And one of these objects was of course that supernova we just recently discovered. And we know that supernova remnants are actually all over the place. Like there's this beautiful one you see right here, there's also another one that's a little bit behind it, so these objects are pretty common. But because they're so large and also because they're so vibrant, it's usually really easy to see them, at least in certain frequencies, in certain spectra of light. And generally, we believe that approximately every 30 to 50 years, there's going to be a supernova producing these supernova remnants somewhere in our galaxy. Here's actually an image from 1994 of a Type 1 supernova from another galaxy, something that we know happens in our own galaxy as well. And though there should be around 1200 supernovae visible to us, at least statistically speaking, we've so far only discovered about 300 or so. And so a huge majority of these supernovae are somehow invisible to us. Now, not so long ago, I've talked about this unusual discovery of another supernova that was only visible in infrared light, and also another supernova that was only visible in the X-ray light. And a lot of these new discoveries were only made because we now have a lot of really powerful telescopes specializing in those frequencies of light. And specifically for this study that we're discussing today, which as always you can find in the description below, all of this relates to this beautiful German/Russian telescope known as Rosita that was launched approximately 2 years ago, and since then was able to produce a lot of different discoveries, including the most accurate X-ray map we have so far of the night skies. The map that has already helped us discover some really incredible features in the galaxy that I've discussed in one of the previous videos. Anyway, so a lot of these new discoveries are essentially because of these incredible new telescopes. And one of these discoveries, made completely by accident, was once again a strange and really large supernova-like shape, which the scientists now believe was produced by a supernova for sure. That probably happened anywhere from about 21,000 years ago to maybe about 150,000 years ago. And unlike previous unusual discoveries coming from this telescope, including these unusual circles that we've discussed in the previous video, this one seems to possess an extremely typical of supernova shape. It really looks like a cloud, but it's only visible in the X-rays. Here's actually a more realistic picture of this, showing where it's located and also showing that, well, it is kind of difficult to see, but it's definitely there. The scientists decided to name this Hoinga, which apparently is a medieval name for the town where the main scientist is from. So basically it's named after the town where he was born. But considering the fact that it's about 90 times the size of the full moon in the night skies, how is it that we missed it for so long? Well, apparently, according to the scientists, we didn't really miss it. It just nobody noticed that it was a supernova remnant until now. The previous X-ray telescope that was used by a lot of scientists, known as ROSAT, apparently has seen it as well. Here's an image from that particular telescope, but for some reason it was missed until now. Probably because Rosita just has much better resolution, much better sensors, and is able to create much more vibrant images, something that previous telescopes just couldn't do. And because of this, the scientists were definitely able to see this and realized exactly what they were looking at. And by the way, just to give you a perspective of how extremely large this object is, let me try to use this representation of the night skies that was produced by Rosita, and we've talked about this in one of the previous videos. So this right here is the Milky Way galaxy. These are the large Fermi bubbles that we've discovered not so long ago. And right about here, right in this location, that's the size of this object. So this chunk right here, or let me actually increase the resolution here, that's basically it. And that's a really, really large object. It actually appears to be one of the largest X-ray objects we've detected in the galaxy. And so far, Rosita has definitely helped the scientists to discover a lot of objects that were previously completely invisible to us or were missed for one reason or another. But the other interesting discovery in regards to this is actually the location of the supernova. Now normally, most of these supernovae we discover are in the galactic plane itself. More often though, these remnants are found closer to the center of the galaxy, mostly because that's where we usually find a lot of massive stars that typically produce Type 2 supernova. Type 2 supernova, as a reminder, is when a very massive star suddenly collapses, creating a really large explosion, which is the supernova remnant, and leaving behind a neutron star or a black hole. But it just so happens that this particular supernova, that we can refer to as Hoinga for now, is basically not in the galactic plane. It's a little bit above it. Something that's sort of visible in this image right here. Now, what does this mean? Well, this kind of implies that it was probably produced through the other type of supernova that usually leaves behind really large remnants. That's of course Type 1a supernova, which happens when a white dwarf, such as what our Sun is going to become in the next few billions of years, basically reaches instability either because of some mass coming from another star or because it collides with another white dwarf. When this happens, when this so-called Chandra limit is reached, it kind of undergoes a lot of instability on the inside and eventually explodes, releasing a tremendous amount of energy and a huge amount of material. And these types of supernova, these Type 1a supernova, can happen anywhere in the galaxy, or can even happen outside of a galaxy, like in this case right here that we've observed back in 1994. And in some cases, especially when it happens outside of the galactic plane, as all of this material expands, in order for it to be observable from Earth, it actually has to interact with something. In some cases, it's gas from other stars or basically interstellar gas, but in other cases it could be some other particles. But because this particular supernova seems to have happened outside of the galactic plane, there's probably just not as much material for it to interact with, and it's thus unable to produce optical light. But it's interacting with something because it's producing X-rays and also seems to produce infrared light as well. So this is actually a great opportunity for scientists to try to understand what happens outside of the galactic plane and to maybe even discover some other mysterious particles like the dark matter particles. With the other implication, of course, being that there's probably a lot more of these supernovae hiding all over the place, just in the spectrum of light that's not visible to us, not visible to Rosetta, and currently not visible to any other telescopes. Which of course just means that maybe we just have to start producing telescopes that can observe other spectra of light as well. It's obviously going to be expensive and might require a lot more effort, but I think it's worth it. We might discover a lot more mysteries and a lot more unusual events somewhere out there that we've never knew existed. And also, since approximately 9% of all of the stars in the galaxy are white dwarfs that could hypothetically explode and produce these supernova remnants, it only implies that a lot of these supernova remnants are all over the place, but we just don't have any ability to see them just yet. Although at the moment, there are still even a lot of questions about this particular remnant. Even the distance to this remnant is not currently known. The estimates suggest that it's either between about 1500 to maybe 4000 light years away from us, but if it's much closer to us, then it means that it's probably even larger in size than we initially assumed. And so more observations are needed from probably other telescopes or from using other sources of light like infrared to essentially try to determine how far away this object really is from us. Either way, it's a super exciting discovery, something that a lot of scientists and a lot of astronomers always dream about, finding something really incredible somewhere out there, something that no one else discovered. And in this particular case, it literally was there this whole time. Nobody really noticed it. Or maybe people have, but they thought someone else has discovered it. And turns out nobody has. Well, anyway, we'll definitely talk more about this as we learn more about this particular object, or as we discover more unusual X-ray objects somewhere out there. For now, well, that's pretty much it. Check out the paper, which as always is in the description below, and that goes through a lot more detail that I haven't covered in this particular video. And if you've enjoyed this video, don't forget to subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support the channel on Patreon by buying the Wonderful Person t-shirt or by joining the channel memberships. Stay wonderful, I'll see you tomorrow, and as always, bye bye.